Alright, so let's start off with some warm-up problems from the previous chapters that we've been learning about. So I brought up a problem where you're subtracting matrices and where you are multiplying two matrices. So first off, when we're subtracting or when we're adding, it's really important that you know that what is the size and if they match. So in order to subtract or add, they need to be the same size. Now in this case, this one's a 2-row and 2 columns. So this is a 2 by 2, and this one's also a 2 by 2. And so because they're the same size, you can subtract them, and when you subtract them, it's going to produce another 2 by 2. So it should produce the similar matrix. Now, when you're subtracting, you just want to take the corresponding number. So in this case, 5 corresponds with -1. It's in the same spot. And just subtract. So 5 minus -1, 5 minus -1. The two negatives make a positive, so this is really 6. So you'll add 5 with 1, you get 6. 3 minus 2 gives you 1. 10 minus 6 gives you 4. 7 minus 8 gives you -1. So this is -1 here. And so then we have our new matrix. So this is the difference of these two matrices. Now for multiplication, it's a little bit different. So you're going to have to check the size as well, but this one is not as finicky. It doesn't have to be the same size. What you have to check is the inner dimensions. So if the inner dimensions, so these two numbers on the inside happen to be the same, which they are, if they're the same, you can multiply. And the outer dimension, so this 2 and this 2, tells you your size. So we're going to get a 2 by 2. Now, what I'm going to do this time just to help us out is this helps out people who are struggling with keeping their matrix in order. So I like to create a grid system to show the 2 by 2. So this is 1 row, 2 row, and then I'll split this to make a column. So that's 1 column, 2 columns. So that's 2 rows, 2 columns. And what I'm going to do is show the work inside each box. You'll see how this is super helpful for figuring out what to multiply. So just as a review here, remember we only grab rows. Oops, sorry, that's a highlighter. We only grab rows from the first matrix and columns in the next matrix. So what I mean here is that I'm going to multiply this row with this column here. So I'm going to take the first row, multiply it by the first column, and you'll see that it goes in this very first spot because this is the first row, first column. So in this case, when you multiply the row and the column, you multiply the corresponding numbers. So the first number with the first number in this column, the second number in this row with the second number in this column. So 1 times 6 is 6, plus, because you always add after, so 4 times 3 gives you 12. So once you multiply the corresponding numbers, you add them together. Now, notice how I need this number that goes here, right? And this is in the first row, second column. So I need to multiply now the first row with the second column. So that's going to give me, well, 1 times 4 is 4, plus 4 times 1 is 4 again. And so you'll notice here now I just have the second row left. So that means I have to be done with this first row. I'm moving on to the second row. Also notice I'm out of columns, so I can't keep using this. So in this case, I'm going to erase these highlighted and start over again. So again, I am now in the second row, first column. So when I multiply, 5 times 6 is 30, plus 0 times 3 is 0. And then last but not least, I'm going to multiply this last row with the last column. So 5 times 4 is 20, plus 0 times 1 is 0. And so now I'm just going to clean this up by adding the insides together. So I'm going to get a 2 by 2. So 6 plus 12 gives me 18. 4 plus 4 gives me 8. 30 plus 0 is 30. and 20 plus 0 is 20. And voila, I have my product matrix. And that's it. So hopefully this grid system will help you out with those problems where you're having a hard time figuring out what to multiply to what. Okay, so let's move on into what we are going to be learning today. So today I'm going to be talking to you about finding a determinant. And determinants are described using these vertical lines, almost like it looks like an absolute value sign, but it's not. So basically, finding a determinant is like an operator. Like an operator is something like a symbol that tells you you're supposed to add. So a plus sign means you add two numbers or two things. A minus sign means you subtract two things. Well, when you see a vertical line on a matrix, that means to find a determinant. Now, to find a determinant, for this case, it needs to be a 2 by 2. So 2 rows, 2 columns. Now you'll see here's the formula. So the determinant of A, which is a matrix here, is A times D. So A times D would be these two multiplying each other minus B times C. So how I think of this is basically when you find the determinant, you just multiply diagonally from left to right. And so that's your first number that goes here. Subtract it with the other diagonal multiplied. So from right to left, so B times C, and then you should get a number. So let's try that here in this matrix that is asking for the determinant. So to start here, I'm going to multiply by diagonal, so that's going to be 2 times 7, which is 14. And I always subtract when I'm finding the determinant. Notice there's a subtraction here. So then I need to multiply it by the other diagonal. So negative 9 times 6 gives me negative 54. Well, because I noticed those two negatives, this is going to be 14 plus 54. And so if I add, this actually gives me 68. So 68 is my answer. So basically what I'm doing is multiplying by the diagonals and then subtracting it. So in this next one here, I'm going to do the same thing. And we always do the diagonal that goes from left to right first, so this way. So 1 times negative 3 is negative 3. And we're going to subtract that by the other diagonal. So 4 times 10 gives me 40. And then if I subtract negative 3 with so subtract negative 3 from 40, that's going to give me negative 43. And so here is my answer. So determinants is using this formula here, where you're basically multiplying diagonally and then subtracting it. And you should get some number. So in the homework, you're going to see 3 problems that is just asking you to find the determinant, and it's very similar to this type of style. So I'm going to show you why do we learn determinants and like how does this involve with something we've already learned. All right, so the reason why we learn determinants is we want to involve it in something called Cramer's Rule. So Cramer Rule helps us with systems of equation. You might be familiar with systems of equation because we touched base on it last semester. Basically, it's where you're given two equations and they're typically in standard form and you're trying to solve for x and y. So in this case, you can see that there's a number in front of x called some sort of a and b in front of y and then c that's outside on the other side. So I just want to mention here as clarification, your a, b, and c here are just coefficients or just constants that are in this equation or these two equations. So I thought I'd make a note of that. And so what we're going to be looking at is how can we solve the x and y if we know what's the coefficients in front of the x and y and maybe the constant itself. So you can actually use the determinant formula to help you out. And so you'll notice here, if you want to find x or solve for x and you're given two equations, all you have to do is take the determinant of x, whatever that means, with the determinant of the system. So D, big D with no subscript is just a determinant of the system. So here's what I mean. So notice how there is a fraction here. That's just the fraction itself. And so determinant, again, uses these vertical lines, so I'm going to go ahead and use that. So we're going to start with the bottom piece here. So D is taking the determinant of the entire system. So what that means is basically the numbers or the variables in front of x and y. So the coefficient in front of x is a1 and a2, and I'm going to write that down. So in here, I need the coefficients of x and the coefficients of y. So this is going to be b1 and b2. So now I have the determinant of the system, and here's the nice part. Since x uses d in the bottom, y also uses d, and I'm just going to copy and paste this over here. So it also uses a1, a2, b1, b2. So I'm just taking those coefficients in front of x and y and putting them in the denominator's determinant. Now for the top, it's a little bit different, but I'll show you some tricks on how I remember. So for x, basically what I remember is that your b's will line up and be the same. So in this case, notice how b's are just the numbers in front of the y. Well, turns out x uses it again, basically. So I'm going to put b1 and b2 directly above where it was in the bottom. Now, on this side, notice how I haven't used the constants. Well, actually, the constants go beside b. So for x, how I remember is that the b's always line up. Basically, the coefficients for y always line up on the right-hand side. For y, it's the opposite. The a's will always line up. So basically, the left side will always line up. And then the c's will be on the other side. And that's just some tips to help you remember how do you find the determinant for dx and d and dy and d. Okay, so in the next slide here, I'm going to show you an example of how you can use systems of equations. How can you take a system of equation and use something called Cramer's Rule, so these two formulas, to solve for x and y. So here I have a system here. And like I said, in the first semester, we learn about systems of equations. We learn how to solve using elimination, graphing, and substitution. Well, here I want us to use Cramer's Rule, because Cramer's Rule is very easy to code into computers. So Cramer has very much advantages now in our today's technology to help compute or solve for systems of equations very efficiently and effectively. So here I have two equations, and I need to know the coefficients in front of every variable. So in this case, this would have been a 1 in front of x, that's a -5, that's a -4, that's a -2. So using Cramer's Rule, I'm just going to rewrite the formulas here. You don't need to rewrite them. I'm just going to rewrite them here so I can see them. So for x, that's when you use a1, a2, b1, b2, a1, a2, b1, b2, just because the denominators are always same with each other. And x's, the b's line up, and with y's, the a's line up. And then the rest are just your c's. All right, so in this case here, to use this formula, x is going to equal, for this case, the coefficients in front of x and y. So remember, a's are the numbers in front of x, b's are in front of y, and c is just your constant that's sitting outside. So in this case, a is 1 and -4, so I'm going to write that in here. 1, sorry, that should be +1 and -4. B here's -5, -2. So all I did was copy those coefficients, stick them there, copy those coefficients, and stick them there. And y is basically the same, right? It's the same on the bottom. So I'm just going to basically copy this over to the other side here, since it's the same. And now I'm going to work on the top. So the top, the x's, the b values are the same. So I'm literally just going to take my b values and stick them up here. So that's going to be -5 and -2. And then c goes on the left-hand side. So that's going to be -5 and 20. And then for y's, my a's line up. So this is going to be 1 and -4. And c will go on this side here. So that's going to be negative 5 and 20. And so if I work this out, I do need to keep track of the top and bottom separately for now. So the top part here, I have negative 5 times negative 2, which is positive 10, minus the other one here, if I take negative 5 times 20 gives me negative 100. And this is going to be over 1 times negative 2, which is negative 2, minus, well, in this case, negative 5 times negative 4 is positive 20. So this turns out to be 2 negatives make a positive, so this is 110 when I add. And the bottom here is negative 22. So if I work this out, 110 divided by negative 22 gives me negative 5. So x here is equal to negative 5 for the first one. Now this other one here, I can just work it out. So I'm going to have 1 times 20, which is 20, minus negative 5 times negative 4 gives me positive 20. And then the bottom's 1 times negative 2 is negative 2, minus negative 5 times negative 4 gives me minus 20. So in this case here, I have 20 minus 20, which is 0 on top. And then negative 2 minus 20 is negative 22. Also, I'd just like to mention, I wouldn't have to have worked this out because it should be the same answer as it was previously. And it is, right? So that's still a negative 22 for the bottom. So if you wanted to skip just this part and just write negative 22, you could do that. And so here I have 0 divided by negative 22, which ends up being 0. When 0 is on top and you divide, it ends up being 0. So y equals 0. And I'm done. So it's pretty easy if you know how to use this formula. So I definitely keep practicing using this formula. I'm going to try out some homework problems from the packet now. So if you want to stay tuned, in the next slide, I'm going to work out a couple problems from the packet. So here I have a problem from packet 8, page 3, and here's a system. And so first, I'm going to make sure I know all the coefficients. That's a negative 1, that's a 4, negative 2, 5, and negative 4. So from here, I need to figure out, what is my x, what is my y, and like I said, both of them uses that formula. And so if you need that formula, I'll write it up here. But make sure you look at your notes too if you don't understand it, how I got there. So the bottom is just your a1, a2, just your coefficients in front of x, and then your b1, b2, which is the coefficients in front of y. And in the top, x's line up with b's, and then c's will fill in the missing blank. For y, the a's will line up, and then the c will fill out the rest. All right, so to kind of fill out my x's first, so x on the bottom here, so this is the determinant of the whole system, so that's going to be negative 1 and negative 2 because those are your a's, right? So negative 1, negative 2. My b here is 4 and 5. And then if I need C here in a moment. So remember, if whatever this is on the bottom is going to be the same as for Y on the bottom. So I'm just going to literally copy and paste. Now the top part for X's above your B values is the same value. So this is going to be 4 and 5. And then this opposite side of it is going to be the constant, which is negative 2 and negative 4. And then for Y's, the A's are the same. So this is going to be negative 1 and negative 2, and then the other side is going to be your c's, so negative 2 and negative 4. And then from there, all I need to do is cross multiply or find the determinant of each one. So this is going to be negative 2 times 5 is negative 10 minus 4 times negative 2 is negative 16. And then the bottom here, negative 1 times 5 is going to give me negative 5 minus, oops, let me highlight that. Negative 1 times 5 is negative 5. 4 times negative 2 is negative 8. So in this scenario, I have in the top, this is going to be a plus sign, so that's going to be a positive 6. In the bottom here, that's going to be a plus sign, so that's going to be a positive 3. So it looks like 6 divided by 3 is 2, so x equals 2 for the first one. So I have the first answer, x equals 2. The second one here, if I were to work it out, remember, this part here, negative 1, 4, and negative 2 and 5 is the same determinant as it was on the other side, right? These two are the same. So that means I could just grab the answer that I got in the denominator, which end up reducing to 3. And then for the top part, I'm going to have to solve it out. So again, I have to multiply diagonally. So negative 1 times negative 4 gives me positive 4 minus negative 2 times negative 2, which gives me positive 4. So in this case, the top here is going to end up being 0 divided by 3, which ends up being, well, 0 divided by 3. When 0 is on top, this ends up being 0, so y equals 0. So it looks like x equals 2, y equals 0. All right, let's try out one more problem. Number 7 here's next. Okay, so I'm not going to rewrite the formula here, but I am going to still work it out by hand. So x equals this determinant over the other. I'm just setting things up first. And then you had the other one. All right, so down here below, you're going to need the coefficients in front of x and in front of y. So this is negative 5, negative 2, negative 5, negative 4. And then this would be the same determinant. So I'm just literally copying and pasting. Now for x's, it's the b's that line up. So this is going to be negative 5, negative 4. So remember, this is your a, b, and c. And then this side here is your c value. So that's going to be negative 5 and 16. On this side here, the a's will line up for y's. So this is going to be negative 5 and negative 2. And then c goes right here, which is going to be 25 and 16. Oh, I think I wrote, yeah, that's weird. I wrote a negative 15 here, but that should be a 25. That's so weird. So that should have been a 25 right here and a 16 right there, since these are your c values. And then these are your c values, but they're just on the right-hand side. So from here, I'm going to just work this out. So if I work out the top one here, 25 times negative 4 gives me negative 100 minus negative 5 times 16 gives me negative 80. And then the bottom, I'm going to have negative 5 times negative 4, which is negative 20. Oh, sorry, not negative 20. That would be positive 20. Negative 5 times negative 4 gives me positive 20. Minus negative 5 times negative 2 is positive 10. So in this case here, 20 minus 10 gives me 10. These will become plus signs, so negative 100 plus 80 is going to give me negative 20. So if I divide, this is going to give me negative 2. So it looks like x is equal to negative 2. For the other one here, we have for y. But remember, the nice part is that we've already figured out this determinant, right? It's the same as the x's denominator. And so that value ended up being positive 10 in the end. So I'm just going to shortcut this. As for the top, I do need to multiply this out. So negative 5 times 16 gives me negative 80 minus 25 times negative 2 gives me negative 50. So that ends up becoming a positive sign. So negative 80 plus 50 gives me negative 30 divided by 10, which is negative 30. So y is equal to negative 30. Sorry, not negative 30, negative 3. So it looks like x is equal to negative 2 and y is equal to negative 3. And that's it. Hopefully this helps you out with the homework.